Okay, we're going to begin chapter 6, section 2, where we discuss trigonometric functions. All right. This first little bit of the lesson, it looks like a lot of information, right? And it kind of is. But I'll explain it in as much detail as I can without it getting kind of dense or confusing, and then you're going to see the actual examples aren't so bad. But before I jump right into the actual definitions of what these things are, there's some things in here that might look familiar to you guys, right? You guys have seen these trigonometric functions before, right? You guys have seen sine, cosine, and tangent. And you guys probably remember this using SOHCAHTOA, right? SOHCAHTOA, let me write it down. All right. And then what this means is that sine in a right triangle, right? We only use SOHCAHTOA in terms of a right triangle. So let's say this is our right triangle. This is our angle theta. We call this side opposite of that angle. The side that's next to it, we call that the adjacent side. And then the side across the right angle is the hypotenuse, right? So sine of this angle theta is the opposite over the hypotenuse, right? Cosine of this angle theta would be the adjacent over the hypotenuse. And then tangent of this angle theta would be the opposite over the adjacent, right? So that stuff should be familiar to you guys. Now, that being said, you're probably wondering what is all this extra stuff in this, what is all the extra stuff that we see on the screen? Well, if we take an angle in standard position, right? Last lesson we talked about an angle in standard position. If we take an angle in standard position and it passes through a point in the coordinate plane. So for example, if you look at this first quadrant, we have a point right here, x comma y. And this terminal side, as you can see, is passing through that point. One thing that you can do to find the trigonometric ratios of this angle theta right here is to kind of drop this little point down to the x-axis, and then you get a little right angle right here. And then notice the shape that you get from this is a right triangle. And then so you can find sine of this angle, cosine of this angle, and tangent of this angle just by using SOHCAHTOA, right? You see that the opposite side is what we label as y. All right, the adjacent side is the side that's right next to this angle, and that's the x coordinate of that point right here, this point x comma y. All right, and then notice that the hypotenuse is just the distance from the origin to this point right here, right? So the hypotenuse is this r value. R actually stands for radius, right? It stands for the radius of a circle, but you guys don't see a circle here at all, right? These angles actually, if you were to draw a circle passing through that point, these angles actually work really nicely with circles, right? But you guys probably won't learn about that for another little bit, all right? But that's what you should take from this right now, right? From this right now, you should take that in the first quadrant. If you draw a little right triangle based on this point that it passes through, right, you can label the sides as follows. And that's why if you look up here, whoa, hang on. Okay, if you look up here, we have that sine of theta is y over r. Well, y is always going to be the opposite side of our angle theta. And r is always going to be the hypotenuse. Same thing with cosine. If you take cosine of an angle, x is always going to be the adjacent side, and r is always going to be the hypotenuse. Same thing with tangent of theta. We have y over x. Y is always the opposite side, and then x is always the adjacent side. Now, there's stuff over here that is new, right? You guys probably haven't seen this in geometry. CSC is shorthand for cosecant. All right. SEC is shorthand for secant, and then COT is cotangent. All right, and then what do we notice about cosecant, secant, and cotangent? Well, cosecant is r over y, which is the reciprocal of sine, right? So sine and cosecant go hand in hand. Same thing with secant and cosine, right? Secant and cosine also go hand in hand, right? Because cosine is x over r, secant is r over x. You just take the two numbers and flip it. And then cotangent and tangent go together, right? Cotangent is x over y, and tangent is y over x. Again, just take the two numbers and you flip it. All right. One way that I like to remember it is that since you flip them, the s should go with the c, right? So s goes with c. So sine wouldn't go with secant then. Sine would go with cosecant, right? Because it has to flip. And then the same thing with cosine, right? Cosine wouldn't go to cosecant, right? It has to flip, and it goes with secant. Cotangent and tangent are pretty easy to remember, so I won't really explain that too much more. But notice that this is true for any quadrant, right? If I were to take a point in the second quadrant, for instance, you still have a point x comma y. The vertical distance is the opposite side of this little angle on the inside, which is the y value, right? And then the side right next to it is the x value, that's the adjacent side. And then once again, the r value is the hypotenuse. And then notice, if you look in the third quadrant, it's the exact same thing, right? There's a little point right here, all right? And then you see that even if you go in the third quadrant, the opposite side is y, the adjacent side is x, and the hypotenuse is r. And in the fourth quadrant, exact same thing, right? If you draw an angle in the fourth quadrant passing through this point, the y coordinate would be the opposite, the x would be the adjacent, the r the hypotenuse, all right? Notice that the signs of x and y are going to change depending on what quadrant you're in. So in the first quadrant, this point is both positive and positive, right? X and y are both positive. In the second quadrant, notice that x is negative and y is positive. All right. In the third quadrant, x and y are both negative, and in the fourth quadrant, x is positive, y is negative. So that's how we can determine the signs of x and y. One thing to note is that the r value is always going to be positive, right? Think of r like the radius, right? Or the distance from the origin to this point right here, right? And you can't really have a negative distance, right? So r is always positive. And then we have up here the relationship between x, y, and r is you would use Pythagorean theorem. And you guys know Pythagorean theorem as a squared plus b squared equals c squared. In this case, a and b are the legs, c is the hypotenuse. So that would give us x squared plus y squared equals r squared is the relationship between x, y, and r. All right, again, a lot of information. Let's go through the next two examples, and you're going to see that they're not so bad. All right, so this is how the questions are going to be worded, right? We have the terminal side of an angle in standard position passes through 8, 15. We want to find the 6 trig values, right? Anytime we're asked to find the 6 trig values, that just means we want to find sine, cosine, and tangent, and all of the reciprocals, right? So cosecant, secant, and cotangent. Right? So I want to find those 6 trig values. To do that, I would first draw a picture. All right, so 8, 15, I know that an x coordinate of 8 would be somewhere right there. And then a y coordinate of 15, probably somewhere right there, right? So we have a point right there. The terminal side of an angle theta in standard position passes through that point. So that means if I were to draw a line, a little ray right there, then this right here would be my angle theta. All right. And we can find these 6 trig values by making a little right triangle. All right. So if I were to draw this little point connecting to the x-axis, we get this little right angle. And then we have that the opposite is the y coordinate. The adjacent is the x, and the hypotenuse is r. Now, we have x and y already. Right, so I'm going to write that down, right? We have x equals 8, y equals 15, and we don't know what r is, right? But what we can do is we can use Pythagorean theorem, right? X squared plus y squared equals r squared. And so this is going to get us 8 squared plus 15 squared equals r squared. So this gets us 64 plus 225 is r squared. And so we get 289 is r squared. And then if you square root both sides, you get r is 17. Once again, we don't do plus minus just because r is always a positive number, right? It's a distance. All right. Now that we have x, y, and r, let's find the 6 trig values, right? So sine, keep in mind that that is x, I'm sorry, not x, that this is y over r. Y in this case is 15 and r is 17. So that means sine is 15 over 17. Cosine is x over r. X is 8, r is 17, so we get 8 over 17. And then tangent is y over x. So we're going to get 15 over 8. And then that's all we have to do to get those 3. Now to get the reciprocals, all we do is flip them, right? Remember, cosecant goes with sine, so this one is r over y, right? So this one's going to be 17 over 15. Secant goes with cosine, so this one's r over x, so this is going to be 17 over 8. All right, and then cotangent goes with tangent, so this one's x over y. So this one's going to get us 8 over 15. And those are our 6 trig values. That's all we have to do. All right, let's try the exact same thing with the next one. We're given a point, -3, -4. Let's just kind of sketch it out. Eventually, you won't have to sketch it out, right? You can kind of figure out this information just by doing x squared plus y squared equals r squared and labeling x, y, and r. All right, but we have that x is -3, 1, 2, 3, and then y is -4. So right there. So we have a point that looks something like that. And then we have this angle right here, right? So this is our angle. We can't really find our 6 trig values just like that. So what we do is we draw a little right triangle. All right, and then this is a right angle right here. And then I have that my opposite is y, the adjacent is x, and the hypotenuse is r. Once again, we would do x squared plus y squared equals r squared. And then we would get -3 squared plus -4 squared is r squared, so 9 plus 16 is r squared. And then we get 25 is r squared. Square root both sides, and we get r is +5. All right, so then let's label everything, right? We have x is -3, y is -4, and r is 5. So then let's find our 6 trig values, right? Sine is y over r, all right, y over r. So that means this is going to be -4 over 5. All right, cosine, all right, is x over r. So then we know that this is -3 over 5. All right, and then tangent is y over x. And then y over x is -4 over -3. The negatives cancel out, so this is +4 over 3. All right? And then to find your reciprocal functions, you can just flip them. So then I have cosecant is -5 over 4. All right, we have secant is -3 over 5. I'm sorry, -5 over 3. And then tangent, or cotangent, is the reciprocal of tangent. So we can flip 4/3 and make it 3/4. All right, and those are 6 trig values. All right, a little bit of work, but hopefully nothing too crazy. All right. We can do the exact same thing for this one. We have a point -4, 0, right? So let's just draw this out. Notice though that -4, 0, I have 1, 2, 3, 4. It's going to be this point right here. We cannot draw a right triangle out of this. So that means a picture isn't really going to help us that much. So this is why it's super important for you guys to understand that x y and r relate to each other by Pythagorean theorem. You still can use x squared plus y squared equals r squared. All right, x in this case is -4, y in this case is 0, and we don't know what r is. So let's solve for it. We have -4 squared plus 0 squared equals r squared. And so we get 16 plus 0 equals r squared. And so we get 16 is r squared, and then when we square root both sides, we get r is 4, +4. All right? Now let's use the x, y, and r definitions of these 6 trig ratios, and we're going to get sine is y over r, which is 0 over 4, so 0. Right? Cosine is x over r, so -4 over 4, and -4 over 4 is -1. Tangent of theta is y over x, so then we get 0 over -4, and 0 over anything is just 0. All right, and now let's find the reciprocals, right? Cosecant is going to be r over y, which is going to be 4 over 0, and anything over 0 is undefined. So you don't want to mistakenly put 0 for that one, right? You want to make sure that you say undefined. All right, secant of theta would be r over x, so 4 over -4, which is -1. And then cotangent of theta would be x over y, which is -4 over 0, and we have a 0 on the bottom again, and that's also undefined. All right, so then those are our 6 trig ratios for that function. I'm sorry, for this particular problem. All right, so this page kind of outlines the reciprocal identities, which just tells you that sine is the one that goes with cosecant, cosine goes with secant, and tangent goes with cotangent. And then similarly, if you're given cosecant, you can flip it to get sine, right? And so on and so on, right? So we kind of already talked about this, but yeah, essentially what you do if you're given sine and you want to find cosecant, for example, you would just flip it. All right, that's really all this slide means. So if you look at this page, we're given that secant of theta is 5/3, and we're asked to find cosine. Well, keep in mind, cosine is x over r, and secant is r over x. So that means all we have to do is flip this, right? 5/3 becomes 3/5. Simple as that. Sine goes with cosecant, right? So for this example, to find sine of theta, all you have to do is flip what you have for cosecant. So this is going to be -2 over the square root of 6. All right, and then when you rationalize this, keep in mind you don't want a radical in the bottom ever. So let's rationalize it. We're going to multiply the top and the bottom by the square root of 6. So we get -2 square root of 6 over 6. And then 2 and 6 simplify to 1/3. So then this gives us negative square root of 6 over 3 as our value for sine, right? Shouldn't be too difficult, right? Maybe some of us forgot how to rationalize a denominator, but that's the step that you would do, right? You want it with no radical in the bottom. Okay, so this page has a couple other identities that we will use and talk about. The most important being the Pythagorean identities, right? Those are going to be the most useful when you're solving some problems. The solution intervals at the top, they just tell you what answers you can expect to get when you solve for sine and cosine, or secant and cosecant, or tangent and cotangent. All right, it just kind of tells you, another way that you can think of it is the range of the function. Range of a function. Right, when we get to graphing, that's going to be after your Easter break. When we get to graphing, you're going to see that the graph of sine and cosine kind of go up and down and up and down and up and down, and they never go past 1 or -1, right? So no matter what value you plug into theta, you're not going to get a number past 1 or -1 unless you multiply that by another number. All right. Similarly with secant and cosecant, since they are the reciprocal, it's going to be every single number other than the ones in that little shape right there. Right? The actual graph for those look kind of funky, right? They kind of go up and then down and then up and then down. But basically there's like this little gap in between where you never get answers, right? So you only get answers bigger than 1 and less than -1. All right. Again, not super important that you know that right now. It's a good way to check your answers sometimes, but I wouldn't worry too much about it. The quotient identities just tell you that sine and cosine give you tangent or cotangent. All right, so sine over cosine gets you tangent, cosine over sine gets you cotangent. We don't really use that one too much in this particular lesson, but what I really want to talk about are the Pythagorean identities. We do use these a lot in this lesson. The next page has a couple problems that we use these identities in particular. Notice that they are called Pythagorean identities because we see squares, right? Sine squared, cosine squared, tangent squared, secant squared, right? Cotangent squared, and cosecant squared. You don't have to memorize anything on this page, right? We give you all of this on a test or a quiz. But it's good to know how to use them. So let's just say, if you remember from the previous slide, I gave you cosecant, and then I said find sine. Well, that was easy because all we had to do is flip it. But let's just say I gave you cosecant, and then I said find cotangent. All right? Well, cosecant and cotangent don't really relate to each other in terms of x, y, and r, but they do relate to each other with a Pythagorean identity. All right, so just by using an identity like that, we're able to solve for a missing trig value that we're looking for. All right, and you'll see what I mean in the next slide when we actually solve for these problems. Okay. We're asked to use the Pythagorean identities to find the following. It says find secant and cosine if tangent is equal to 4/3. All right, well, we want to find two different things. The first thing is we want to find something that relates to tangent. All right, so if you look at your identities, again, you can look at them, you don't have to memorize them. Is there anything that we can do with tangent that would get us either a secant or a cosine? All right, and there is, right? We do have an identity, right? We have 1 plus tangent squared theta equals secant squared theta. All right, so then what I'm going to do is I'm going to take this value 4/3 and I'm going to plug it in to that tangent right there. So then this gives us 1 plus 4/3 squared equals secant squared theta. And then all I have to do is solve this for secant. So we get 1 plus 16/9 equals secant squared theta. And then get a common denominator. This is going to get us 9/9. So we get 25/9 is secant squared theta. All right, and then you can square root both sides, and then you get, let me write that up here. We get secant of theta is plus minus 5/3, right? Now, which one is it going to be? Is it going to be positive or negative, right? I'll tell you right now, it's not going to be both. All right, so what we're going to do is we're going to use this information right here. We're given that theta is in quadrant 3, right? So give yourself some room on the side. I'm going to explain something really quick, all right? So we have quadrant 3 is right here, right? So this is quadrant 3. Now think about the signs of x and y in the third quadrant, right? X is negative and y is also negative. All right, secant, if we remember, is r over x. If r is always positive and x is negative, that means that secant is going to be negative. All right. Now, you don't really want to think about this particular way every single time you come across a problem like this. All right. And that's why I typically will just show you guys that in the first quadrant, all of the trig functions are positive. So everything is positive. In the second quadrant, all right, so this is quadrant 1. In the second quadrant, only sine and its reciprocal cosecant are positive. And in the third quadrant, only tangent and its reciprocal cotangent are positive. In the fourth quadrant, only cosine and secant are positive. All right. And one way that I like to remember this is all students take calculus. All right, all students take calculus. So in the first quadrant, everything is going to be positive, all of them. In the second quadrant, all right, all students, sine, S goes with S, so sine and cosecant go together. So that's the only ones that are positive. In the third quadrant, right, take, all students take, so tangent, T goes with T. Tangent and cotangent go together, that's what's going to be positive. And then in the fourth quadrant, cosine and secant are positive. All students take calculus, C goes with C. And so cosine and secant go together, and those are what's going to be positive. All right. We are given that here that theta is in quadrant 3. So the only things that are positive in quadrant 3 are tangent and cotangent. So that means secant is going to be negative. So that means our value for secant of theta is just going to be 5/3, right? I'm sorry, negative 5/3. So secant is negative 5/3. All right. The next thing that we were asked is cosine, right? Cosine goes with secant. So that means all I have to do to find cosine is to flip this, right? Because cosine and secant are reciprocals of each other, right? We get negative 3/5 for cosine. All right, that's all we have to do. It's kind of a lot, but I'll show you the next one. It's going to be a little bit smoother. All right, let's try the same thing. We're asked to find cosecant if cotangent's negative 1/2. Ask yourself, is there an identity that relates cotangent with cosecant? And there is, right? We have 1 plus cotangent squared theta is cosecant squared theta. So all we have to do, let's plug in the negative 1/2 in for this cotangent. So we get 1 plus negative 1/2 squared equals cosecant squared theta. So that gets us 1 plus 1/4 is cosecant squared theta. And then, again, find a common denominator. 4/4 plus 1/4 is 5/4 is cosecant squared theta. And then when you square root both sides, you can square root the top and the bottom. So this is cosecant of theta is plus minus the square root of 5/2. Since we're in the fourth quadrant, again, think about all students take calculus. All right, in the fourth quadrant, it's just cosine and secant that are positive. All right, cosecant is not one of them. So I'm going to scribble out the plus. It's just negative. So cosecant of theta is negative square root of 5/2. All right. Again, a lot of material in this particular lesson, but again, adequate practice should do the trick, right? And then we'll have plenty of time for review as well. But otherwise, that's it for this lesson.